Welcome to The Explainer. Today, we are going to tackle asynchronous JavaScript. This is the secret ingredient that stops your favorite apps from freezing up and keeps them feeling lightning fast and super responsive.
You know the feeling, right? We've all been there. You click something and boom, the entire page just locks up. You can't scroll, you can't click anywhere else. It is just so frustrating.
Well, that annoying freeze, it's caused by something called synchronous or blocking code. But don't worry, JavaScript has come up with some really powerful solutions over the years. We're going to walk through that whole evolution from the very first clever fixes to the super elegant code that we get to use today. Okay, so to really get a handle on this solution, we first have to understand the core problem. And it all comes down to a key feature of JavaScript. It's single-threaded. That means, out of the box, it can only do one thing at a time. Think of it like this. Synchronous code is basically a single-lane road. Tasks have to run one by one. If one car is going super slow, guess what? Everybody behind it is stuck in a traffic jam. But asynchronous code, that's more like a multi-lane highway. You can start a long, slow task in one lane, but all the other traffic just keeps on flowing in the other lanes. That's what keeps the application feeling responsive. And here's what that looks like in the code. Step 1, the program logs start. Simple enough. Then, step 2, it hits a really slow task, maybe a big network request. Now, in a blocking world, as you see in step 3, the whole application just freezes. It just sits there and waits. And only after that long, painful wait does it finally get to step 4 and log end. That freeze is the user experience nightmare we're here to solve. So the very first solution developers came up with was actually pretty clever. It's kind of like telling someone, hey, I'm busy, just call me back when you're done. And this simple idea led to something we call callbacks. So what is a callback? It's literally a function that you hand over to another function. You're basically saying, hey, run this code for me, but only when you've finished your long, slow task. It's a way of deferring an action until some operation is totally complete. And here's where the magic really happens. We can call a function like make fried egg, and because it's asynchronous, our code immediately moves on to the next line. Console.log, making toast, without waiting at all. The main program just keeps on chugging along. Then, whenever the egg is finally ready, that function we passed in, our callback, gets called with the finished egg. The app stays completely responsive the whole time. Now, callbacks work for sure, but what happens when you need to do a whole bunch of asynchronous things one after another in a specific order? Well, you get a very, very messy kitchen. And this right here perfectly captures the chaos. Let's say you want to make toast, then fry an egg, then add cheese. To do that, you end up nesting one callback inside another, which is inside another. This deep sideways drift is famously known as callback hell, or my personal favorite, the pyramid of doom. It's a total nightmare to read and a real headache to try and debug. Callback hell was a huge problem, so the JavaScript community came up with a much cleaner, way more organized solution, promises. Okay, think of a promise like a receipt you get at a restaurant. Right now, you don't have your food, but you do have a guarantee, a promise that you'll either get it eventually, or someone will come tell you there's a problem, like they ran out of an ingredient. So every single promise goes through a life cycle. It always starts in the pending state. That means the operation is still running. From there, it can only go one of two ways. It either gets fulfilled with a successful result, or it gets rejected because something went wrong. And once it's settled one way or the other, it's done. That's it. And this is the beauty of it. Promises completely flatten that pyramid of doom. We can now chain our actions together. We start with toast bread, and then when that's done, we move to the next step. It creates this clean, vertical sequence that's just so easy to read. And best of all, if any step in this whole chain fails, the error is caught by a single dot catch block at the very end. So much cleaner. Promises are awesome. They really are. But modern JavaScript gives us an even more elegant syntax that's built right on top of them. And this, folks, is the ultimate fix for writing clean, asynchronous code. Okay, so here's our breakfast sequence using those promise chains we just talked about. We call toast bread, then we handle the result, then we call make fried egg, and so on. It's a clean, logical flow, and it's a massive improvement over callbacks. But what if we could make it look even simpler? And here it is the modern way. Just by marking a function as async, we unlock this magic await keyword. Now look at this line here. Const toast equals await toast bread. It looks like the code is just pausing right there.
But here's what's really happening. The function pauses without blocking anything else. Once that promise settles, the result gets assigned to our variable and we just move on to the next line. Our asynchronous code now looks synchronous, but it's just as non-blocking as it was before. It's the best of both worlds.
And that's it. Just two little keywords, async and await, completely transform our code. This is what people call syntactic sugar. It doesn't actually change what promises do underneath it all. It just gives us a sweeter, cleaner way to write them. And trust me, that makes a world of difference for readability.
So, we've gone on this whole journey, right? From callbacks to promises, all the way to async await. But why is this progression so important for you to really get?
Well, this evolution is the absolute foundation of pretty much every modern web application out there. It's the reason you don't get that frozen screen anymore. It's what allows for those smooth user experiences. It lets servers handle massive amounts of traffic without getting stuck. And ultimately, it lets us developers write clean, understandable code instead of a tangled, confusing mess.
Look, understanding this journey doesn't just teach you syntax. It gives you the power to build better, faster, and more professional applications. So the next time you use a perfectly smooth app, you will know exactly what's happening behind the scenes. Thanks for watching The Explainer.